Next topic, it's a little bit about security. So as you know, when you have a big system, okay, this is just what we had before. Open Science Grid is a big system, right? It is widely distributed. It's continent-wide and even beyond that. It has many participants, thousands, tens of thousands of users and administrators. We have just moderate trust. There is no way that everybody knows everybody else. When you have thousands of users, it simply doesn't work. And there are many local HC technologies because sites may have existing infrastructure. They have already installed system, already users there when they join the Open Science Grid. So it's a very complex system. So here you have a picture of what OSG was. Ignore the various colors. I couldn't get it without. But you see that in the US, it's pretty well distributed, at least below this point. And you see that we have also sites from all around the world, although the vast majority, it's in the US. It's jointly funded by NSF and DOE, who pay your school too. And has partner grids all over the place too. So a lot of what you can do on OSG, you can do on other grids because there are continuous efforts being done so that the various grids interoperate. So you can use an OSG client to submit the EGI and the way around. Just a little bit of history so that you wouldn't think that OSG is something that was created yesterday. It actually, its root go in the past millennium, just before 2000. And it started as with different names, but essentially everything that was done here eventually helped shape the OSG as it is today. Now, OSG is heavily high energy physics dominated. It's not all high energy physics, but high energy physics is a big player. And the reason is that high energy physics simply cannot live without the grid. They need so much computing that the grid was the only option forward. So they pushed a lot, they invested a lot in the grid, and this is why they are a big player. But several other physics community have also big needs for computing, so they followed shortly afterwards. But in the past few years, a lot of others have realized that grids, in the end, make sense. They have some drawbacks, but in the end, make a lot of sense, and they are joining the Open Science Grid. So today, Open Science Grid, it's really composed of pretty much any science you can think of. Just some numbers. The number of sites on OSG is around 50, plus minus 10, more on the plus side than on the minus. The sites range from really tiny, small clusters of about 10 probably nodes, not cores, to the biggest ones that are approaching 10,000 cores. So you see the range is really huge. And the amount of manpower behind those sites is also very different. The small sites may just have a tenth of a graduate student or even an undergrad doing everything from installing security patches, monitoring, you name it, he does it. While the big ones actually have a team of system administrators that do nothing but look after their site. So the kind of support you will get at different sites can change a lot. And the number, on the other side, the number of users is huge. I just ran a query across the number of users that are being used of some of the major sites, and it exceeds 10,000. So it's true that not all are active at the same time. We probably don't have 10,000 users submitting all the time. But of these 10,000 users, they have used the grid at least once. So there are actually 10,000 individuals out there to take care of. So we have a scale problem, right? When you have hundreds of sites and tens of thousands of users, how do they get together. You cannot just assume that each user will ask for an account at each site. It just doesn't scale, right? Does anybody agree on this one? Or I was just too excited when I was writing the slides? Do I have an eager student here, or are you just, everybody's just sleeping here? Everybody's sleeping? OK. So if you use an overlay system, right, it's not a problem of yours. You just submit to a local system, and everything just works, like it did today. When you submit it to the Glidance, you didn't have to do anything. It just worked. You went to UNL, you have to Chicago, you went to USSD. Nobody asked you for anything. It just worked. But, of course, somebody still has to send the Glidance, so it doesn't work by magic. So I will explain you still why it is a problem and why this is needed. And anybody seconds this one? No? Everybody sleeping still? OK. Well, you are here because you said you are interested in this kind of stuff. So this is why I'm explaining it. But more seriously, you will need it for storage. While the overlays may help you with the jobs themselves, you still will, Brian will tomorrow tell you that you still need to manage the storage yourself, and it's just not as magic as the overlays seem to make it look like. So bear with me and follow up what I have to say. So when you want to go to a highly distributed system, you still want to preserve a single identity, right? You don't want to have a different password for each site you go to. You just want to say, hi, I'm Igor. Okay, let me in. I want to run the jobs. Do I get you right? Would you rather do something different than just this? No, it seems natural, right? This is exactly what you want. Yet, most people, for everything else, they use the username passwords. And that really doesn't scale, doesn't work when you have really a lot of systems. So how many passwords, username passwords do you have when you go to the various websites? Tens? More? So we want to avoid that. And the reason why you have so many passwords on the websites is because sharing passwords between sites is really a bad idea. Because a password is a shared secret between you and the service provider. If service providers start to share password between them, soon it's not a secret anymore. The secret is really secret if very few people know about it. Having hundreds of sites know your password, it's a really bad idea. So we will not use username passwords. So what can we use? The idea is to find a trusted third party that will vouch for us. So instead of having a username password for each and every site, I will have, let's say, a username password for somebody I really trust and that sites trust. So I go to the site and say, here's my username password. Can you get me something that the sites will trust to let me in? So I go to it, say, I'm Igor. Do you trust me? Yes. OK. I give you this passport, and I present this passport to the site. Here, see, he let me in. Can I get in? Yes. Thank you. And you get in. So in real life, we do this all the time. And I use the passport for a reason. Or I should use an ID or the driver's license. This is what we do all the time. When you go anywhere, do people trust you at face value, literally at face value, that you are who you claim to be? No. They want to see an ID. And they look at your name and say, oh, yeah, you are John Smith. But why they trust that piece of paper or plastic that you are John Smith? Because it was issued by somebody they trust. And this somebody they trust, it can be a government, a DMV, or somebody that they can trust. We want to apply exactly the same logic to the technology we are using. We're not inventing anything new, just applying common sense to technical problems. There are many technical solutions out there. There is X509, Kerberos, OpenID, Shibboleth, name it. There are long list. And they are all based on exactly the same basic principle. The technology, the small details may be different, but the base principle is the same. Have somebody highly trusted that you use as an intermediary. OSG has standardized on X509. I will not argue it's the best one, but that is what it is, and this is what we will discuss. It's not too bad, but I will not argue it's the best. So what is X509? It's a public key cryptography system, and it's based on public key cryptography. The idea is that you have a pair of keys, one public, one private, and they are strongly related. You can use the private key, the public key to encrypt and the private key to decrypt, and you can use the private key to sign and the public one to verify that the signature is right. I will not go into technical details how this works. Google it if you are interested. There is a lot of math going on. There are several implementations that are available. The most famous is the RSA, which is uses prime numbers. There is the ecliptic curve cryptography, that is another one. And I think there are others that are being proposed. But the RSA is by far the most used in the real world, for whatever reason, mostly historical. And in X509 PKI, the highly trusted person is the so-called certificate authority. And this is the one that gives you a certificate, and the certificate has your name in it. So it tells whoever you present the certificate who you are, a private public key pair, and it's signed by CA private key, so that anybody that wants to make sure that the certificate is valid can actually verify it. Like when you have a driver's license, you have these funny pictures on it that the cops look at with ultraviolet light. The CA signature is the equivalent of that. So nobody can fake it. You actually need to get it from the trusted certificate authority. And you yesterday had gotten a certificate from DOE Grids. So DOE Grids is the CA, and you got a certificate that was exactly this. And this is, you had to use it today partially, and we'll go a little bit more in details with that. So how this works? When a user has a certificate and wants to authenticate with the site, what it does, it sends the public part of the certificate. Of course, you never want to send the private key, right? Because it's private. If you send it, it's gone. The site replies and say, here is a random string. Please sign it with your private key. The user uses his private key, makes a signature, sends it back. At this point, the remote site verifies that the public certificate is valid using the pre-installed CA public key. At that point, it is sure that the public key in your certificate is valid, verifies the signature, and if everything went right, it says, OK, this is exactly who he claims to be, in this case, Igor. And they say, hi, Igor. I trust you that you are who you are because you presented a valid certificate. So nothing magic, a little bit of math, and the thing is done. So we use X509 as a single sign-on in Open Science Grid. So once upon a time, you talk to somebody, the DOE Grids. The DOE Grids wanted some proof that you were who you were, so they asked Alan if you really are the person who claimed to be. And Alan said, sure, give them the certificate. You got the certificate running the second script, and now you have a certificate that you can go to all the sites. So this is the magic thing that you have been doing that you have done yesterday. This part can take a while. You are having Alan here, it was very fast. Or in real life, usually takes a day or two. But once you have it, it is good for a year. So for a year, you can use this to go to all of OSG and use the resources. Now, a slight problem you have with that is that, yes, you can submit a job and get to the worker node. But what happens if this job actually needs to do something on behalf of you? For example, talk to the FTP server, right? You may need to transfer a file from somewhere else, and you want to do it in an authenticated way, just because you don't want everybody to get that file, or you want to upload something to the FTP server. Typically, you cannot do it without a login, right? So how do you do it? Right now, it seems it's pretty much impossible. The job is not you. They don't have your certificate. So this one will say, what are you talking about? Go away. And the reason why is this is because the job doesn't have a private key. And it should not, because it is not you. And if you start sending your private key around, it will not stay private very long, right? As I said, secrets are only secret as long as very few people know about it, possibly only you. But we have a very similar problem in real life too. I hope nobody of you ever went to court, but if you have to go, you probably will have somebody represent you. And you may not even be present for the initial round of discussions. So what you do usually is give an attorney a proxy letter that says he's authorized to speak in your name. We want to do exactly the same thing for the job. So that just like in a court, nobody will trust that the attorney is you. All we want to say is this person can talk in my name. So the way we do it is by creating a proxy. And this is what you do when you do a grid proxy init or bounce proxy init. You effectively create a short-lived, a new certificate out of your original certificate, which is not the same, but it says this proxy, it's something that the job can use to perform actions in my name. And once you have it, you send it alongside with the job to the worker node so that the worker node can use that proxy to talk to the third party. And since that thing it's effectively a certificate, it works exactly as before. All the cryptography is done the right way. Everything is verified. Nobody can fake that it is you, and so on. Now, of course, there are some risks of doing this. You are effectively sending a private key over to the site. So somebody could steal it, right? We trust the sites not to do it, but the site can get hacked. So how do we minimize the damage if a site that I delegated the proxy to misuses my trust? Yes?
The certificate, the job certificate, has its own private key?
Yeah, it's completely different from the original one. It is related to, but it is completely different. More questions? No. So, as I said, how can we minimize the risk? The way it is done in OpenSense Grid is just imposing strict timing limits. All proxies should be short-lived. And what is short-lived, it's up to discussion, but definitely less than a year that your certificate is valid. Typically, it's a few hours, but you still need to make it long enough so that it's longer than the lifetime of your job, because typically you want to transfer files at the end of the job. So at the end of the job, the proxy still must be valid. Plus, you may be sitting in the queue for some time, so you have to account for that too. So what exactly is very limited? It's sort of muddy, and for a lot of users annoying, but it is important. So don't be tempted to just create year-long proxies and use them, because while they will work, if anything goes wrong, you will spend a lot of time recovering. So if you have a proxy that is valid for 12 hours, it's stolen by somebody, after 12 hours, any damage that attacker can do is gone. If it's valid for a year, it's a different story, right?
What if I need some load calculations?
You, well, you will not be able to run on OSG for few months for sure. Most sites impose a limit of a day, maybe 2. So anything you do, your job must be long for a day at most. Well, you can submit many jobs that in total will take a year, but each single job should be short. You can obviously renew your proxy every day so that every new job will get a day worth of proxy. But you should never try to submit a job that you expect to run for months. You have actually 0% of. Not in the grid. Well, you can sort of do it yourself, but then from the grid point of view, your job is short. It's not a month-long log. You can do it yourself. You can, for example, after 12 hours, dump your state to a file, transfer it to a file somewhere. The next job that starts loads it and starts exactly where it's finished. But it's all your problem. From the grid point of view, they are different jobs. Tell me.
So one thing to note is the Condor grant has mechanisms to auto-update proxies.
Yeah.
They're not typically exercised because people just create a proxy as they want. But if you felt super paranoid, you can actually make do with a 3-hour proxy and just make sure it gets renewed every hour. It will actually push it all the way, if you're using Condor G, through the compute element to the worker node, or if you're...
At least in theory.
Yes, as Igor says, at least in theory.
Yeah.
Under the assumption, computer science assumption of people don't test it out often enough. But it should work in this portability just
Right.
that you can push out updates to a running job and keep it very short.
Yeah.
It's one of those where how paranoid you can be. And then also, to involve some of the checkpointing, there are tools that you can use that will do the checkpoints for you that are fairly robust.
Right, but from the grid point of view, they are different jobs. So while you build your checkpoint infrastructure independently of the grid, it will, from the user point of view, may seem completely transparent, but it's not embedded in the grid itself. So you can do a lot of things on top of the grid. Right now, we are just explaining the basics, and then there are plenty of tools that take the basics and do pretty much everything you can think of. And if they do, if you want to invent them, it would be great. More questions? No? Okay. So just a word about delegation, and if you use an overlay, you still want to use a proxy when you use an overlay like glidance, because you still may want to use a third-party file transfer from the worker node. So if you don't have a proxy, you will not be able to, because the worker node still doesn't have access to your private key, even if you're using glidance. You can, the problem is pretty much the same. It's just, as Brian said, Condor G supports proxy renewal. It just works a little better in the overlays. And there are some features in Condor that you can have a really long-lived proxy locally on the disk, but Condor will automatically shorten it before delegating it to the worker node, and tricks like that. It just makes life a little easier. But to the first degree, it makes no difference if you use an overlay or direct grid submission. You still need a proxy on the worker node. So this is all nice and dandy, but we are not done yet, because the fact that a site knows who you are does really tell the site that they should let you run. And I have a usual cartoon. And who wants to second this one? Come on, I want some participation, come on. Anybody's eager to say, I use the overlays, I don't care. Because it is true, when you use overlays, you don't care which site allows you in. Somebody behind the scenes have already done it. So your job is to run wherever the glidings can run. So why do you want to care? Nobody? Come on, come on. Somebody tells me, why should I care about this part? Come on, guys. Okay. No, the job will just run if you use the glidings. Somebody did the magic for you.
Why do you trust me? Why would you offer me your glidings?
It just works, trust me. No. One reason is the pilot still needs to be authorized. So, and since this is an OSG school, you want to know how it's working behind the scenes. So it's important for you. And of course, I hope you agree with this. And as usual, there is storage. When you go to the storage, yes, you have your proxy, and your proxy needs to be authorized to the FTP server. There is no overlay that can help you there. So you still need to learn it, even if you are not interested in behind the scenes, which you should be. You're here exactly for this reason, I hope. So one must never mix authentication and authorization. They are two completely different things. Just because somebody somebody recognizes you and says, okay, I trust you, you are John Smith, doesn't mean that it will allow you to do anything. An example I have here, just because I have a driver license and I show it to the guard in front of the nuclear plant, doesn't give me access to the nuclear plant itself. They will look at it and say, oh, nice to meet you, Igor Sfiligoi, but go away. Right? That's the most likely reason. Why the heck should they let me in? Although they authenticated me just fine. They have no problem with that. But authentication and authorization are two completely different steps. And X509 just covers authentication. Just tells the site who you are. They tell nothing about the fact should they let you in or not. So in Open Science Grid, each site decides by itself who will let in. There is no way for anybody on top of OSG say who should be allowed in a site and who should not. We can ask. We do ask. But it is up to the